Hello friends, welcome to this video. So today we will be discussing about RMO 2023 problem 3 and let's start with this problem. The number 3 question. So let's see. For any natural number n expressed in base 10, let Sn denote the sum of all its digits. Find all natural numbers m and n such that m is less than n and s of m square equals n and s of n square equals m, right? So we are given this condition. Now the thing is that what is s? So let's first get a feel of s. So for example, s of 100 is 1, right? Because 1 plus 0 plus 0, and but s of 65 is 11, right? Because 6 plus 5. This means that if a is greater than b, then it's not necessary that s of a will be greater than s of b, right? Another property that we know is that s of n is congruent to n mod 9 mod sorry is congruent to n mod 9 and but we won't really use this property much in this problem, but it's something good to know because of course why not. And let's start with the solution. So clearly, as you can see, n is the square of something, so it's a perfect square. Similarly, m is the square of something, so it's also a perfect square. Let m equal to a square and n equal to b square. Okay, then we can just rewrite it as s of a square, which is s of m, will be equal to b, and s of b square will be equal to a. So now, and we will claim that both numbers m and n have to be less than 1000. And suppose it is possible, basically we prove that there has to be maximum 3 digit. Okay. Suppose it was possible for m and n not to be to be 4 digit or higher. So we will disprove that thing. Suppose n is greater than 1000. Okay. We're assuming as a case. B, then b, which is n squared, will be greater than 31, right? Because 31 squared is 961. And so since b is greater than 31, but b is also equal to s of a squared, so s of a squared is greater than 31. And as you know, the maximum sum that you can achieve if the number is 3 digit, that is 999, so the maximum sum of digits will be 27. But since we want a sum greater than 31, then we will have to go to 4 digits, right? So a square will be a 4 digit number, and in fact the smallest 4 digit number which has sum of digits 32 is 5999. Okay, so that's 5999, so a square has to be larger than it, right? The thing is that square root of 5999, like the closest is, the lowest square is 78 square, so you can like calculate it, or so a is greater than equal to 78. And we also know that now we are using one more very important thing, that m is less than n, right? Since m is less than n, it means a square is less than b square, because m equals a square, n equals b square. So it means that a is less than b. So since here we get a is greater than equals to 78, it means that b is greater than 78. So it is greater than equals to 79. So s of a square is greater than equals to 79. पहले हमारे पास 31 था, and then we got 79. And since s of a square is greater than equal to 79, and the smallest number with sum 79 is very big, it's 7 and then followed by 9 8 times. So it's actually, if I write it down properly, it's 7999999, because 9 times 8 is 72, and 72 plus 7 is 79. Okay, and if you take the square root, then you get 28285, right? The lowest one is 28285. So a is greater than equals to 28285, b is greater than equal to 28286, and then s of a square, which is equal to b square, is greater than equal to 28286. And we continue this pattern for this pattern will get continued, and you get a square greater than equal to every number. So basically a square will just blow up to infinity, and you basically won't get any solution. The proof that a square will blow up to infinity is also very important, because it's you need to prove it. Suppose a square is greater than equals to n, that is something suppose we have established this result, that a square is greater than equals to some n, and n is usually like it's a very big number, like something like 286 or something like that, right? Like, I mean, what I'm saying is the smallest number with sum of digits 28286 will be very large, okay? And so n here also is very large, it's extremely large, right? And so a square is greater than equals to n. So a is greater than equals to 1 plus floor of square root of n, okay? And this means that b b is greater than equals to, I mean 1 plus की जरूरत नहीं है यहाँ पे, in fact square root of n will work as well, but it doesn't really matter. b is greater than equals to square root of n plus 1, right? So s of a squared is greater than equals to, I mean you can just write 1 instead of 2 everywhere, but it won't really matter, just to be specific. S of a square which is equal to b will be greater than equals to square root of n plus 1, and this will mean that a square is greater than equals to this number. Now how do I get this weird number? The thing is that this number, so basically this number is nothing but some power of 10 minus 1. And what's some power of 10 minus 1? Like, what is any power of 10? Looks like 1 0 0 0 0 0 0, right? And if you subtract 1 from it, you will get 9 9 9 9 9 9 9, something like that, right? So something like that. Okay, 9 9 9 9 9. And we also know that the smallest number which has a particular sum of digits is leaded by multiple 9s, right? So as you can see, 9s are there, 9s are there. So if we just take square root of n ka floor plus 1 divided by 9, these many 9s, then we'll accomplish a sum of square root of n plus 1, and then there might be some number in the front as well, some one digit number, but we don't need that, because we will get a contradiction before without considering that number as well, right? And if you just see, so if you are taking 9 these many times, so you have the exponent of 10 as that as exactly, and you minus 1 as well. So a square is greater than equals to this big number. And the problem with this thing is that since n is very large, this number obtained is very much greater than n, and you can prove this using exponents. Basically this is like you can think of it as an exponent only, because square root of n plus 1 divided by 9 is greater than n ka square root by 9, right? And we have n. So let's suppose let's write square root of n as x. Then can I write a square is greater than 10 to the power 1 by 9 whole to the power x, right? I mean you can just kind of just minus some things here, some small things here. And a square, initially we had that a square is greater than x squared, and since this is an exponential graph, it obviously will exceed a polynomial at some point. I mean this is a well-known fact, so you can just directly write it, and it is exceeding, right? So you go from 599,000 to 5999 to 7999999 to a very larger number, and that means that a square basically just blows up to infinity, right? So the logic used here is that an exponential curve which has a base greater than 1, like for example कुछ भी मान लो ना, say for example e power x, 2 power x, 10 power x, 100 power x, anything. And if you have a polynomial equation, for example x square, x cube, or x cube plus 5x plus 65,000 or something like that, it eventually the exponential curve has to cross the polynomial curve. And the one more important thing is that once it crosses, So once the exponential curve goes ahead the polynomial curve, then polynomial curve will never able to cross the exponential curve again, right? So that basically means that, so basically we have proved that n as b square has to be 3 digit. Okay, so let's move on to the second case of our question, in which we deal with 3 digit numbers. Now the good part is that we have eliminated a lot of cases, which is a very good news, and that basically means that so let's rewrite the equation. S of a square equals b and s of b squared equals a. Okay, and we have that a square and b squared are both less than 1000. So a and b are both less than 31. So now we are dealing in a very constrained space. Okay, now let's check these cases, right? So if a and b are less than 31, suppose a square and b square are both less than 1000, so it implies s of a square and s of b square are both less than 999, right? Because 999 ka sum, which is nothing but 27. So as you see, this thing is less than or equal to 27, because you can't achieve a sum of digits more than 27 for 3 digits, right? 3 digits or lesser than that also. So this basically means that a and b, and since s of a square equals b and s of b squared equals a from here, so we get that b and a are less than or equal to 27. Okay, now let's check some of the numbers. So for example, 27 squared is 729, and 729 has a sum of digits of 18, right? 7 plus 2 plus 9 is 18. So 27 squared is 729. So iska sum of digits will be 18. Okay, and the maximum sum of digits that you can get for 3 digit numbers less than 27 squared, like 3 perfect squares less than 27, is not very large. So for example, 27 squared is 729, so the sum of digits is 18. 26 squared is 676, so the sum of digits is 25, right? 25 squared is 624, so the sum of digits will be 625. Sorry, here it will be 19. I'm 6 plus 7 plus 6 is 19. 625 के लिए the sum of digits will be 13. 24 squared equals 576, and the sum of digits is again 18. 23 squared is equal to 529, so the sum of digits is 9 plus 7, which is 16, right? 22 squared is 484, so the sum of digits is 16. 21 squared is 441, sum of digits is 9. So you basically see that the sum of digits will never exceed 19 also, and 19 squared is 361, and that sum does also that also does not exceed, like 361 ka sum is 10, so like it's just going down. 20 squared is 400, so that's 4 there, that's very small. 19 squared is 361, as we just did right now. No, 19 squared is 361, and if you go below 3, then you won't really get a sum which is greater than any square below than 19 square has to be, so for example, let's say 18 square, so here you get 10, and 18 square is 324, where you get 9. 17 squared is 289, where you get a big number, which is 19 again. Okay, below 17 square, any number is 2 followed by 2 digits, right? And like 15 squared is also, 16 squared is 256, which is 5 plus 6 is 11, 11 plus 2 is 13. 15 squared is just 225, which is 9. Let's just stop for now. As you can see, 14 square will be 196 and the numbers you get will be lower and lower. The highest sum that you can get from a square which is less than 200, so it has like, suppose maximum at max it can have 1 as a digit here, right? And 9 maybe. So that will be 19. 19 is the maximum sum of digits that you can get. And since 19, so basically we don't need to consider the numbers above 19, because anyways below above 19 we are not getting any match. As you can see, as 27 squared is 18, but 18 squared we have 9, so 9 is not equal to 27, right? 26 squared is 19, 19 squared is 10. I mean sum of digits I am speaking, so it's not a match. 10 and 26 don't match. 25 squared is 13, but 13 square will give 169. 169 is 16, so that don't match. They don't match. 24 squared is 18, but 18 squared is 9, so they don't match again. 23 squared is 16, but 16 squared is 256, which is 13, so they don't match again. 22 squared is 16 again, and they again don't match because 16 squared is 13. 21 squared is 9, 9 squared is 81, and that they don't match. 20 squared is, I mean this again clearly doesn't match. 19 squared is 361, and 10 squared is 100, so that number 19 and 1 won't match. And now we'll just take the numbers from 18, and 18 squared is 9, 9 squared is 9, so they don't match. 17 squared is 289, that gives 19, and 19 squared is 361, so 19 also doesn't match. So I mean we can just erase all of these numbers, and we need to basically just consider all numbers from 1 to 13, right? And let's just write those squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. And as you see, I think I skipped one number. I mean, I'll have to still go till 16. 14 squared is 196, 15 squared is 225, 16 squared is 256, right? I mean 17 squared also you can check, it won't really work. And the thing is that if you check the pairs here, it's not very tough to check the pairs here. I'll just write the sum of digits down there. So for 1 it's 1, for 4 it's 4, for 9 it's 9, for 16 it's 7, for 25 it's 7, 36 is 9, 49 is 13, this is 10, this is 9, this is 1, this is 4, this is 9, and this is 16, right? And I'll just take the next numbers. 196 create 16, 225 creates 9, what's after 225? That's 256 is 13. And the thing is that if you check, only these two pairs match. So 169 and 256. So this basically means that S of 13 squared equals 16 and S of 16 squared equals 13, right? I mean you can just check none of the other pairs will match, because you also need them to be distinct, because these won't match because m is less than n, right? And the others don't match at all. So the only solution is 16 squared and 13 squared, which is 169 and 256, and that is also the solution. So the solution is m comma n equal to 169 comma 256. Note that if you write 256 comma 169, you might get your marks cut, because they have specifically given m is less than n. So that's a small detail. So that's all for this question. Thank you for watching this video. Like and share this video and subscribe to my channel. If you have any comments or any general comments about bashing and how to approach this question, you can give it in the comment section. Thank you for watching.